All right. So next lesson here. So we're on lesson 3, and we are going to now be talking about using trig to solve for triangle angles. All right. So we're going to use the same. And we're pretty much living with sine, cosine, and tangent. So the whole SOHCAHTOA trio. We're working with those, and we're going to use those now to, instead of solving for sides, we are going to solve for angles, right? And so we're going to do it much the same way, but there's one big fundamental shift we're going to have to do. And in this video, I'm going to kind of talk about what that is, and then in the next couple videos, we'll actually put it to use. So what I want to talk to you guys about is inverse trig functions, like an inverse trig function. What does it mean and everything? And then in the other videos, we'll get in the nuts and bolts of like how to do it. Okay, so by the time you're done watching these vids, you should be able to use the trig ratios to solve for the angles. So not just the sides, but also the angles of right triangles. Okay, so they'll give you different information that will tell you what you're going to need to use. So it says to solve for an angle in a right triangle, use the inverse trig functions. Input is trig function value, output is an angle. So before we kind of fill this out, I want to just do a little concept talk here. So if you remember what an inverse function is, right? So if we have f of x, right? I'm gonna switch this over here. You'd think by this time I would have figured out how to like make this work right. If you have f of x equals x, right? And we understand that that's the same as y equals x, right? They're kind of equivalent expressions. When you have an inverse function, basically it's saying, well, if you're going to find your inverse function of x, all you do is you switch y and x around, right? So this becomes x and this becomes y. Now in something like this, it doesn't really change it too much, right? But just understanding that this x equals y is represents this, right? It's this function, right? This is your f of x is the normal is sorry, habit writing it like that, right? Is is represented by this, right? And then your inverse function is represented like this. Okay, so just switch them around, right? And so with trig functions, it's very much the same thing. It's like you're switching the things around. So if you think about like what the sign of a function is, right? The sign of a function is it's sine of, we've been writing it as sine of theta equals, and then we go opposite over hypotenuse, right? And that's kind of what we have. So this is like your x, right? And then if you think of theta kind of as y, right? Think of that kind of as y. And then if we're going to do an inverse trig function, the only thing that's different is we're actually going to kind of leave this there, right? So we're going to go sine, and because we're doing an inverse, you're going to -1, and then you swap these around, right? So you go, oh, put the opposite over the hypotenuse over here, and then your theta goes over here. And the thing that's valuable about this is once you have this, you've got an equation to find your angle. That's just like, just plug the stuff in and go, right? It's super easy. And the only real new part of this for you is going to be just how we put it in the calculator. Using the calculator with it just basically involves pushing one more button, right? And I'll kind of talk through that a little bit as I'm doing the problems. But that's kind of the basic idea: is you're treating this kind of like your y, you're treating this as your x, and you're just sort of flipping them around. So even though you should be treating this whole thing as the y, if you just treat this as the y, treat this as the x, and just kind of whoop, flip them around, then you're going to get kind of an idea of how this works, right? So that's how we use these to help us. And so let's just finish filling this out. So they're saying if the sine of A equals x, right? So they're saying this. So you can also think of this as sine of theta, right? If sine of theta equals x, then what happens is when we do the inverse, right, you go sine, and then you use your negative thing. And you'll also occasionally hear this called arc sine, all right? They'll call the cosine arc, cosine, right? And then there's arctangent, right? Now, we're going to use just inverse of sine, right? But if you watch some other videos, you might see that. And so arc stands for inverse as well, okay? So when we're doing this, okay, the arc sine, so flop them around, right? So we're going to put x here. So the sine of x, which is going to be your ratio, right, that you have, is equal to a, which is your angle. So this would be your ratio, right, which is your, in this case, would be your opposite over your hypotenuse, and then this would be your angle. Okay, and it's the same thing for the other two, right? So it would be the inverse of cosine, right, would be your x goes here, and then your a goes here. And the only thing that's different about this is your ratio on this one is your adjacent over your hypotenuse, right? We don't flip them, right? They stay the same order, right? You're just moving, you're just taking x and y, kind of switching places with them. And then tangent, again, the same thing. The ratio stays in the same order, right? Opposite over adjacent, and then equals to a, which is, in both of these cases, right? A is your angle. All right, so that's how we kind of think about how these inverse trig functions work, and then in the next couple videos we will put them to use and go from there. All right, so we'll see you.